Hello and welcome back. We are doing a pause and practice. So we're going to build a character matrix that's going to contain a 2D matrix of characters as the instance variable. So we're actually going to make a class called char matrix that's going to have this in it. We'll have a constructor that will set the size of the board and as well as the symbol that we want to use. And then we're going to also print it out. We could also have I don't know why I wrote constructor twice. We can also have a method that prints out the matrix nicely. And then we're going to build the following method. So let's start with just this basic instruction before we start doing the fill methods. Let's just get a feel for that. So we can go ahead and close out this example that we had from our previous video. We can kill this terminal. We don't need any of that. And we're going to make a new file. I'm just going to do it right here at the same level. We're going to make a new file, and this is called char matrix.java. And this could be our object file. It is going to be a class. We're also going to need char matrix main.java. And it will be a class here as well. So this is what we're going to use to put our main method in that's going to connect to our object class over here. Now we said that we need an array and or a 2D matrix. We said it was going to be 2D, a 2D matrix of chars. So let's go ahead and make that. So a private char 2D matrix. We also can make a couple of variables to help us out with like the number of rows, the number of columns. And there are ways to get these using like the matrix.length and stuff like that. But technically matrix.length, like we can just store them anyway, save us the memory access. It really doesn't matter if you choose to make those extra variables or not, but I'm going to. And then we also are told that we should store the symbol. So we aren't told that we actually need these two, but I'm going to leave them. And I'm going to assume that it doesn't really matter what number the user enters for rows and columns. Now, if I wanted to be like a really truly full crazy example, int rows, int columns, char symbol, I would do things like checking the values that are coming in and making sure that they're positive. I am assuming the rows and calls are non-zero positive values. That is an assumption that I'm making for the purposes of this. You often shouldn't make assumptions. It should either be told to you by us or you should be asking. But for right now, I'm going to assume that this is what's happening so that I can say this dot rows is equal to rows without doing any error checking and making our code just a little bit more simple. And then I can make my new matrix array equal a new char array of size, rows, and columns. That's not how you do that. Rows and columns. There we go. Okay. As part of doing this, I'm going to make a fill all method. Actually, yeah, just so that we can have public void fill all. Whoa. Just so that I can put the symbol in all the spots. So that we have something to print nicely when we do our toString. So I can say for each char array row in my matrix, and then I can say for each oops. Is this the right way to do this? Yeah, why not? For each, we'll see if this works. I'm just trying to think. This should work. For each character element in our row, we're going to make the element equal whatever symbol we have stored. Element equals symbol. And now we can do our toString. Only way we can test this really. And we're going to have actually a very, very similar structure. So I'm going to copy paste this for loop structure, only instead of setting each element, we're going to be doing a system dot, not error, system dot out dot print. We know that it's going to be a single character symbol. It has to be a single character symbol. Yeah, that's what I thought. This isn't going to work. I have to do this using using array indices. That's so interesting. I'll fix that in a second. It will work for here though. So we'll have our symbol. And we'll put like 2 spaces, doesn't really matter. And then we can put our print line. Oh, they're not prints. They're not prints. This is a 2-string. We can say string result is starts off as empty. Instead of printing it, we can just say result plus equals. And then this can also just say result plus equals a new line character at the end of every row, and then we can return results here. Now, this actually isn't going to do what I thought it was going to do because these are primitive values. And if this is a primitive value, it's not actually going to set this dot matrix the way that I want it to set it. Rather unfortunately, but it will not. We lose our reference. I think I can do it like this, and this will be good enough. Where if I say int array I equals 0, I is less than the row dot length, I plus plus, and then I can just say row at I is equal to symbol. Whoops. That actually should work. So now I can go over here and I can make a new char matrix variable. CM for char matrix. It's going to be char matrix, and I have to give it rows, columns, and symbols. Let's start with something easy. 3 by 3. And let's just make the symbol an X for right now. Just hard code it in. If I was going to be really correctly intense about this, I would have a num rows equals 3, num calls, oops, equals 3, and a symbol equals X. And then I'd put each of these in here because I am a good developer, like that. You'll notice that I lose the what's it called? That like gray where it like showed the names of the internal constructor variables when I use actual variables here, because now that I'm not just hard coding numbers in, it expects you to have given it good variable names. So it only really does that if it needs to. Thanks to computers being so smart these days. Anyway, I can now say cm.fill all, and then I can say, let's just like print out our char matrix. And we can actually run this, and hopefully we get exactly what we want, which is a 3 by 3 array with X's. If we make this 10 by 4, we'll get a 10 by 4 array. And if we make this, I don't know, 8 by 8, we'll get an 8 by 8 array. If we make this, let's actually find a fun symbol to do here. Like, let's go here and let's go ASCII table symbols. Just to be fun for a second. And let's see what we can find in this ASCII table. Because I'm sure we can find something really good. Like, oh, like a smiley face is apparently 0, 0, 1. Is that what I want? How I need like the ASCII here. This should give me what I want. So what I can, oh, I guess I can just do 0, 0, 1 as like an int and then cast it to a char. That actually would work. If I just said char, oops, 1, because I don't actually know what it is. Oh, that didn't work. Come on. How about like 15? One of these has to work. I feel like I've done like this, like the hearts and stuff like that before. I feel like I've done those before. And now I really want to. Okay, so now I have to do this. Java char code for smiley face. That doesn't say smiley face. Display the smiley face character in Java because I really want to do this. Oh, here. Is this the one that I'm supposed to do? Not all operating systems can do this. I don't care. We're gonna give it. We're gonna try. Okay, so let's grab this and let's put that in here as our char. Please work. Yeah, we have smiley faces. Oh, I'm so excited. Okay, so now we have smiley faces as our symbol. So that's pretty awesome. I'm gonna leave it like that because that's sick. We're gonna use smiley faces for everything instead of X's. X's are boring. We're gonna do smiley faces. Okay, cool. So now we have a fill all that totally fills all and works, and I'm super excited about this. I'm just gonna comment this out because we're gonna now flip back over here and start talking about how we do these. Okay, first off, we're going to fill the top half. So we're going to make a method called fill top half, and this is what it should do. It should take our symbol and fill the top half rows. Okay, so let's go over here and let's make that method. Public void. Actually, I'm going to make a public void empty method where all it's going to do is basically empty the matrix out. And it's going to do that by making the matrix into a new char matrix with this dot rows. It's just like basically making a brand new one. This dot calls and this dot symbol. But now it will be re-empty. Are you cool with that? Oh, this is equal. You gonna be okay with that? Ooh. I guess I can just do this. I don't know why I'm being so weird. What day is it today? Doesn't matter. Today is apparently a day that's super weird. There, that'll just like empty it out, making all the spots empty again. I also just realized I think what I want to do is I want to make my toString have a way to like, if it's empty, just print out your char array has nothing in it right now. So what is going to be the best way to do that is probably going to be, oh, what's going to be the best way to do that? Oh, this is going to be so annoying. I think the best way to do it is going to be to make a Boolean is empty that starts off as true here and will also be true here. Oh no, fill all will make it false. When I empty it back out, it will make it true. And then here I can just say if it's empty, or I can say if it's not, no, if it's empty, result will just be your char matrix is empty. This should be, for some reason, I didn't put double quotes. And then here I can say else. We're going to do this. There. Okay, so at least now my char matrix is empty when I flip back here because I commented this out and that actually works. So that's great. Annoying that I'm going to do it that way, but great. For each element. Oh yeah, but I'm not using element in this scenario. Well, that's fine. Okay, cool. No, I should be printing the element here. This should be L. That's really funny. I should make sure that this is actually working appropriately because I'm going to fill the symbols and then I should be tacking them on here. Otherwise, the rest of my code is not going to work. As I add more fill methods, this will stop working if I don't do it that way. Okay, so that actually does work. That's great. And when I comment that out, we definitely do get that my matrix is empty. Okay, now I'm in a much better place. I could even add some comments. Empty out all symbols. Oops. Fill all cells with the specified symbol. And this one was supposed to say empty out all cells. Okay. Cool. So now we can actually go back and start working on our fill top half method here. So we have an empty and a fill all. So right here, we can say public void fill top half. That doesn't say top half? Top half. All right. So in order to fill the top half, the whole objective of this method is to fill the top half of the matrix with the given symbol, right? So that's the whole point. So now in order to do this, we have to go through all of our rows and only fill the ones if they're in the top half. So we need to figure out which rows are the top half, right? So which ones are the top half? I wish I was in a classroom right now. Well, we can probably figure out how many rows we have. Oh, wait, I'm so smart. I made a variable. So if I know how many rows I have, I know how many rows I have on the top half. So if I say int half rows, and I say rows divided by 2, I will end up with some value of half the rows. Now, if I have, I'm just going to do this in comments. Let's say that this was like my array. Oops, those should be zeros. I know things. Whoops. And I had 4 rows, so 4 divided by 2 would give me 2. I would just need to go through rows 0 and 1 for this to fill the top half of my rows. If I had, there's like 2 cases. If I had this, I have to make a decision. What is the top half? Is it going to be all 3 of these, or is it just going to be these? Like if there's a middle row, what do I want to consider half? To make my life easy, I'm just going to leave it truncating. So it basically always rounds down. So even here, 5, if we had 5 divided by 2, we'd get 2.5. This would just be 2, and I'll just end up filling these 2. If I wanted to be really fancy, I would fill like half of the middle row or something crazy like that. But I can leave that to you to do if you want to be fancy like that. So all I need to do is I need to go through just the top half of the rows. Now, there are different ways to do this. Some people might make a for loop that goes through their whole array, and then if they are on one of the element, like one of the rows are in the top half, they would fill them. I am only going to iterate. Oh, pardon me. I'm only going to iterate through the top half. So I'll just say while the current row starts at 0, and while the current row is less than half rows, let's run this loop and then go up to the next row. And then within a row, I'm going to look at the cells of that row, but I do have to go through every single cell. So for the, typically we'd say column or C, whatever is 0. While the column is less than, well, I have to be looking at the row we're talking about to know for sure. Now, of course, in this scenario, it's not ragged, and we know our array is not ragged. There's no way to make it ragged. So I could just say while the column number is less than cols. I could also say while the column number at the given row, there we go. So I can say while we're at this current row, the length of the current row, right? So we can do it that way, but because we know that this isn't ragged, we don't have to do it that way. We could just do it this way and go up by each element. Oops. And then all we need to do is set our matrix at our row and our column equal to our symbol, right? So first we get the half row, then we say for each row in the top half, and then here we can say for each cell in the current row. And what are we doing? Set that cell value to the symbol. Okay, so let's actually call this fill top half method. cm.fill top half, and let's just see what happens. Let's just cross our fingers and pray a little bit. My chart matrix is empty. Why is it empty? Fill top half. Am I still calling the empty call somewhere or something? Oh, because when I fill the top half, I have to change is empty to now false. Yeah, I knew that this was going to be annoying. No longer empty. I don't care. I am annoyed that I did that a little bit, but I think it'll be worth it. There we go. So we can see that the top half is filled, but it makes it really hard to even notice if there's anything in the bottom half. So I think what we're going to do is we are going to make a new method called initial fill, and we're going to call it inside of our constructor. And it's going to be a private method. It's not a method to be called from the main class. It's just a method to be used by our constructor. And all it's going to do is basically do fill all, but with a dash symbol. Yeah. I really want to do this in a smart way. That's what I'm thinking about right now. Um, oh, have so many smart ways that I could do this, but I'm struggling to agree to any of them in my brain right now. I will take this. It still is empty, is still true. And instead of filling out the symbol, we're going to fill it with dashes. Won't this have to be like this? Anytime you copy and paste like I just did, there's a good chance that you could do something differently, which I could. I could be making this fill all method actually take in the symbol that we want. And then we could pass in this symbol or we could pass in this symbol. So there are smarter ways that I could be doing this to avoid the mass amount of code that I'm currently writing. And wanting to drive myself a little crazy over. But uh I'm gonna cut my losses and try not to freak out too much about the duplicate code that I just wrote. But this at least now allows us to see that we are indeed filling the top half of this array. And if we go back here and we set this to something that has an odd number, we're going to get what we decided, which was the integer truncation. It doesn't matter if they're different lengths, like the rows and the columns are different lengths, 4 and 5. It'll continue to work, no problem. So it's awesome. So we totally have this fill top half working. When we empty it, I just realized once we empty our array, we also have to initialize the fill to all those empty values. So now what we can do is we can actually start to build out this program in a way that lets us see everything that's happening. So the first thing we're going to do is new matrix created, and we're just going to print it. Then we're going to say system.println fill all spots. So we're going to fill all the spots, we'll print it, and then we're going to empty it. And then we can say fill top half. And then we can fill the top half, we can print it, and then we can empty that as well. And so now every single time we want to do something with this, we're gonna like label it and we'll do the work and print it. We're gonna label it, do the work, print it, right? And we can empty it out in between each one. So now here we can say a new matrix is created and it's empty because we haven't done anything yet. We can fill all of our spots and then we're going to empty it. Then we're going to fill the top half and we can see that that worked. So we're really cooking with gas now. Is that the saying? Okay, so that worked. Cool. All right, let's move on here to a front diagonal. So the front diagonal is the one that starts over in the top left corner and then makes its way all the way down to the bottom right corner. The back diagonal is, of course, going to be the reverse. And then an X in bingo is when you do both. Okay, so let's fill front diagonal. Let's write the method for filling the front diagonal. So let's come right over here. We're going to put it right here to keep our code nice and organized. We're going to fill the front diagonal here. Pardon me. Public void fill front diagonal. Now, it really, really helps when we start to make these sort of more complicated patterns to once again, like think about what that means for us. So let's start here with a 3x3. If we want to fill this one, and this one, we need to fill spot 0, 0. I'm actually going to label these with their XY coordinates, like their row column coordinates. I think that that will actually help immensely with seeing the pattern that I want you to see. This is going to be 1, 2. This is going to be 2, 1. This is going to be 1, 2, and this is going to be 2, 2. So what we can see with this pattern here is that we need to fill 0, 0, 1, 1, and 2, 2. Here, if we make this bigger, 3, 0, 3, 1, 3, 2, 3, 3, 2, 3, 1, 3, and 0, 3. we want to fill 0, 0, 1, 1, 2, 2, and 3, 3. So we can actually see what's happening there. Now, we can put restrictions on this, like it has to be an n by n matrix, like it has to be a square. We could put those kind of restrictions on it, or we can just assume that we're going to do the best that we can. Whoops. And if they give us a weird matrix, we always start at 0, 0, and we make our way down. So that's what I'm going to do, but I am going to write that down. I'm going to say does not require a square matrix. Starts at 0, 0, and creates diagonal as far as it can, right? That's what it's going to do. Diagonal, diagonal, as far as it can. So in this case, it can only go up to there. Okay. So this can be tricky. This can actually be quite tricky. One way that people really like to solve this problem is, I'm going to show it, but it's not how I want you to solve it, is you do that double for loop where you go from int row, row is less than rows, row plus plus, and then people would say for int call, don't write this down. If you're watching this, just watch, just see what people do and why this is not great. Don't actually write it down. And then again, we saw in that example that we wanted to make the changes at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, n minus 1, n minus 1. So what people will do is say if row and column are the same, pardon me, in the matrix at row and column, put our symbol. That is what people will do. And we can run this. We're going to first print out and say fill front diagonal. cm.fill front diagonal. We're going to print it and then we'll delete it after so that we're ready for the next time. And when we do this, what we actually will see is that I, once again, geez, that is going to keep biting me in the butt. Hey, is empty. It's true. False now. That's going to keep biting me in the butt. That sucks for me, but whatever. It's fine. I made a weird choice there. We can see that that works, and we can see that if we want to turn this into a 4x4 matrix to make it work even nicer, that it falls exactly nicely where we want it to fall. And that's great. However, imagine for a second if this was 1,000,000 by 1,000,000. Okay, it's not going to print nicely. Really? You don't work for 1,000,000 by 1,000,000? You're not actually cool with that? I would have thought that it was okay with it. Fine, 100,000 by 100,000. Still no? I'm running out of heap space. Wow. 10,000 by 10,000. Gosh, these double for loops are going to take us a really long time to run through. And we know that because for every element, we're going through every element. We have 10,000 spots that we have to fill. That is actually massive. And this might take too long for me to be cool with. So I'm even going to make it a little bit smaller. That actually should work. That taking this long, I find actually incredibly concerning. 1,000 rows. Oh, no, I don't. 1,000 rows by 1,000 columns. This isn't 1,000 elements. This is 1,000 rows by 1,000 columns. So that's not concerning. If I want to do 1,000 by 1,000, let me just kill this and do it like this. That's funny. This will be 1,000 in total. 1,000, 100 by 100 is going to be 1,000 total. So it doesn't print super nicely just because of the amount of space that we have on here. But in theory, this is 1,000 by 1,000, and it's just printing funny again, because of how much space we have. We're running out of space. Can we do 10 by 10 nicely? I think we can. Yeah. It's interesting, but it makes sense because it's exponential, right? Every time that you increase this, by like a factor of 10, it's an exponential increase because first it was 10 times 10, then it was 100 times 100, 1,000 times 1,000, right? It's n squared. So it is exponential and it does make sense. Anyway, point of all of this being that specifically for this fill front diagonal, there's no reason to touch these elements these elements, these elements, these elements. There's no reason to. We don't need to do it that way. All we need to do is for every single row, place one smiley face. And we place it where row and column are the same. So let's start with that. Let's turn this into one for loop instead of two. This is not going to work on its own 100% of the time. We're going to have to make one more change. But if we just do that and we run it, it's still going to work because now we're just going to do 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now, if I was in class, I would pause right now and I would ask you, when will this break? And unfortunately, we're not in class. So I'm going to just have to tell you when it breaks. And it is going to break. I'm going to do it just on a smaller scale. In the situation where the rows and this actually will work still. The situation where the number of rows is greater than the number of columns, this will break. We get an index out of bounds exception because if we try to reference spot 4, 4, or even spot 3, 3, that doesn't exist. We can only go up to 3, 2. So there is still a way for us to do this with a single loop. We just can't do it like this. What we actually want to do is we want to make that row variable like this. And then we want to say, while row is less than the number of rows and row is less than the number of columns, we can do this. And then row plus plus. And so now instead of having two for loops, we have one while loop that works perfectly well. And so instead of n squared, this now is only n. It doesn't take nearly as long. It doesn't look great to do a front diagonal in a non-square, but that's okay. At least our code does work exactly as we intended to work. Let's run this as well. Okay, that's awesome. It totally works. All right. Fill above diagonal. Okay, so let's do this next. Let's flip back over here. Let's move this out of the way and let's talk about filling that top diagonal. And again, it's always really nice to draw stuff out. It's really going to help us. Public void fill top diagonal if we actually draw something out here. So 1, 2, 3, 4, 1, 2. It's almost always easier to solve it on a square first and then figure it out. And what we want to do here is we want to fill our top diagonal still. Our front diagonal, pardon me. We want to fill our front diagonal, but then we also want to fill every single element that comes off of our front diagonal, right? So we want to fill 0, 0, 0, 1, 0, 2, all the way up to 0, n minus 1, 0, n minus 1, right? There we go. And then here we want to start at 1, 1, and then do 1, 2, and then all the way up to 1, n minus 1. Here we start at 2, 2, all the way up to 2, n minus 1. Here we're going to start at 3, 3, up to 3, n minus 1. It's only that one spot, of course, in that case, but that's fine. And we can see a pattern forming. The pattern is here we started at 0 and kept going to the end. Here we started at 1 and kept going to the end. Here we started at 2 and kept going to the end. Here we started at 3 and kept going to the end. So let's write our code to do that. We're going to start off at 0 because that's our first row. Only now it can't only be one for loop because we're not only putting one element in each row, we're going to put some other number of elements in each row. Now, the first time that this runs, we do want to start at 0, but next time 1, next time 2, next time 3. So in fact, what we're doing is we're always starting at wherever row is, and we're going all the way to the end of columns. And we are filling our matrix at row, column with our symbol. And that's actually what we're doing. That's everything here. That is this picture. It really helps to draw it out first because what we want to do and what we really want to do is use not square brackets. What we want to do is we want to say for every row, starting at the front diagonal point, so where row is equal to columns, fill symbols to end of row. That is what we are doing right here. And we figured it out by drawing it out first. Okay, so now I can leave that code there. I can come over here. I can copy and paste this like a crazy person. This is no longer filling front diagonal. This is filling the top diagonal. This is no longer going to be filling the front diagonal. This is going to fill the top diagonal. And now we can print that out as well. And we're doing it on 5x5 to start. So we can go ahead and run that. And apparently I misnamed it. Whoa. Top diagonal. That was weird. I don't know where that extra S came from. All right. We can see as we've gone through each of these, what's happened. We filled it, we cleared it, we did the top half, then we cleared it, the front diagonal, we cleared it. Oh my God, literally at what point? I feel like I'm doing this on purpose. I'm not. I'm actually not. I'm just having trouble not being an idiot. There every single time. Okay, and now we can see we have indeed filled that top diagonal. At this point, there's lots of things that you could challenge yourself on that I haven't shown you, like the back diagonal, the bottom diagonal, the bottom half, right? There's like the opposites that we can do for all of these. I will leave fill below diagonal for you to figure out on your own. I'm going to upload this code. So what I'll actually do is I'll make the method right here called fill below diagonal. And all it will do is print out fill below diagonal not yet implemented, right? So then that will print out, and then I'll add it to the front end here as well so that you have something to practice with. Fill below diagonal. And this will just, now this actually will correctly, and I'll even put my dumb is empty in here. No, I can't do that. You'll have to make, don't forget to set is empty equal to false, because I just keep forgetting. Okay, so now when we run this, for you to fill it out on your own later, you'll see fill below diagonal, not yet implemented, and then your char matrix is empty. And that's because we haven't actually filled it yet. Now, the filling char matrix is empty is kind of annoying of me, because now that we have these dashes in here, it would have been obvious that it was empty, but like, whatever, it's fine. I'm not going to stress about it. I will do even rows. You will do even columns. No. Yes. Even columns is trickier, but that's fine. I'm going to do filling even rows, and you're going to do filling even columns. So public void fill even rows is going to be a method we're about to do. And then public void fill even columns is also going to be a method. Only this one, I'm going to do the exact same thing I did before. And then on the front end, I'm going to grab each of these, and we're going to do fill even rows, fill even columns, and of course you could do odds, etc., whatever. Fill, whoops. Fill even, I'm supposed to say columns. I'm supposed to say rows. This one can say columns. Oh my God. Okay, so now right now, none of that's implemented, but we're going to do fill even columns right now. So basically what we're going to do is we're going to go through every single column. And if the column is an even column, meaning 0, 2, 4, whatever, we're going to fill it with our symbol. So it's simple enough for us to actually do this. We're going to make sure that we set is empty to false, because I refuse to forget again. We're going to go through every single row, starting from 0, going up to the end of our rows. And we're just going to ask ourselves, is this an even row? If the row is even, which we do by checking it just like that, we're going to then go through all of the cells in that row, and we are going to set them appropriately. So it's really not a hard method to write once you sort of get the flow for writing 2D matrix methods. We can just say matrix at row. Column equals this symbol. So now when we run this, we have some things that are working and some that are still yet to be implemented. Okay, the last one here is a chessboard. The chessboard starts off by filling the even spots and then the odd spots, the even spots and then the odd spots, the even spots and the odd spots. I will actually do this one. It's a really fun one. So I want to do it just because it's fun. Public void fill checkerboard is what we're going to now make. I can spell fill. And we're going to come over here and we'll just add that right in as well. Fill checkerboard. And then this one will say fill. Oh, I called it checkboard. I'm going to fix that. I'll make it called checkerboard. Checkerboard. And then where's my done message? Did I like somehow just delete it? Like, did it just get deleted? Oh, maybe I didn't make one for this. Okay, I'll add a done message over here as well. And processing, just so that we know we reach the end of our file acceptably. Okay. Oh, I want to do this recursively. I'm having so many fun thoughts on this one right now. Okay. I might do it recursively. I might. Let's see. Why not? So what do we need to do? Well, the first row, we fill even call cells. Second row, we fill odd call cells. Third row, we fill even call cells, and so on and so forth, right? We can see the pattern forming here. Now, there are lots of ways for us to do this, but we have to be able to keep track of if we are on an even row or an odd row. So we need to ask ourselves, is this an even row? And by default, it should be true because the very first row is an even row. Now you could do this with math. Like you could be checking each row value being modded by 2, etc. But it's actually really not necessary. We can just use a Boolean to keep track of this. And then we can go through every single row. Whoops. Oh, I'm going to write this like a little bit not pretty first, and then we're going to prettify it. And I'm very excited. So if we're on an even row, we're going to fill even columns. If we're on an odd row, we're going to, is that right? Yeah, we fill the even cells. And if we're not, we fill the odd cells. So if we're on an, if we're on an, we're going to do this in so many smart ways. Cell index starts off as 0. If it's not an even row, we need to start our cell index off at 1. Right? Because when it's an even row, we start here at 0, but when it's an odd row, we have to start here at 1. And then what we can do is we can say, whoops, for our, oh my God, int call is equal to call index, because that's where we're going to start. And then we're going to go for all the way up to the end of the row. And then we're just going to go up by 2, because we're going to skip one every single time. Oh, cell index. Sorry, cell index. Then we can say matrix at row call is our symbol. Oh my God, these brackets are just slowly killing me. I'm really struggling here. Okay. Ooh, I'm so excited. Okay, so this is what we're going to start with. I can't. I forgot. I can't. I hope you all are at home watching this and you are laughing at me. I hope you actually are. I hope you're like, wow, that just keeps happening. Okay, so what happened is we actually ended up with all columns, basically, which means I've unfortunately now shown you how to do fill even columns, but that's okay. What happened? Well, what happened is every single time we finish a row, we need to change is even. We need to flip it. Is even row has to now flip. There are different ways to solve this problem. The first way is to do something like this. Has to happen actually at the very top. Check to see if the row mod 2 is 0. If that comes back as true, it's even. If that comes back as false, it's not even. We could also just do this. Take the opposite of whatever is even currently is. In my head, when I wanted to do this recursively, this is what I was thinking of doing. was flipping it like this. And I am going to update this code to make it recursive just for funsies. There we go. We get our beautiful checkerboard. Now the reason that mine is flipped, it was supposed to start with 0, is because of how I've done this. I have to like set this value initially to false so that when this runs the first time and row is 0, it will become true. That's the only downside to how I've written this. So now I get the checkerboard the same as the example solution. Now, if I wanted to change this to recursive, which I do so badly, I don't know why I'm getting this urge, but I do. We want to start working from the inside out. That is the easiest way to do this because we have 2 for loops to turn into recursive methods. So we're going to make a private void fill call recursive, and it's going to need to run this loop right here. Yeah. So what we're going to do is we're just going to move it in there for a second. Whoops. We're going to pick this up and put it there. We're going to replace this whole thing with fill call like this. That's step 1. Because this allows us to now see the things that need to come in order for this to work properly. We need to bring the row in and we need to bring in the cell index that we're starting on as well. Now, instead of, yeah, that's correct. So what I'll do is I will make those as variables that I'm passing in. So I can pass in the cur row and I can pass in the cell index. I'm trying to think of really clever ways to do this. This became cur row. This became row and cell index. So now if I look at this, my code should actually run the same as it did before. Because all I've done is move the for loop into here. But now I'm going to turn this for loop into a recursive call. I'm going to say if the cur, I have to base it off of this right here. So if the cell index is less than columns, right? That's this right here. What do I want to do? Well, I'm going to do this. Only it's not called call here. I'm leaving it as cell index, which is fine. And then I need to call plus equals 2. So fill call rec per row, cell index plus 2. And that's it. There doesn't even have to be an else because this is the recursive case. And if we don't go into this, else do nothing. Else do nothing. No base case needed. No uncomfortable blank if statements or else statements, no returns, nothing. This is perfect just like this. Awesome. Okay, so next, we need to get rid of this outer for loop now too. So let's make another private method. Private void fill row recursively. And this is going to take all of this and it's going to get plopped right in there. And all this is going to do is call fill row recursively. But this is still a for loop. So in order for this to work the way we want it to, we need to figure out how we can remove this. Whoops. We know that this if statement is actually going to tell us whether or not we need to recurse. So let's turn that into an if statement. If row is less than rows, I'm just going to comment this out for a second. If row is less than rows, this is what we need to do. Now we don't want to set any variables in here because by setting a variable in here, it'll keep getting reset every time this gets called. So this actually is going to have to come out. Okay, now we've got some red, which is actually a good thing. The cur row has to come in. And so does the Boolean is even row. It's got to be passed in so that this can all work appropriately. I'm missing a that doesn't need to be indented. I'm getting messed up because my if statement is funny. If my cur row is less than my rows, I need to do all of this. And then after I fill it, I need to go to the next row. Whoops, just this. Go to the next row. Cur row plus 1. And I don't have to even do this here. I can just pass it in. Ooh. And, oh my God, this is just getting better and better. I don't even need to have cell index here. If I pass in the cell index, oh my God, this is just going to keep getting better. Check this out. If I just pass in the cell index, I can pass in exactly the if statement we originally had, which was cell index mod 2. When it's 0, wait, cell index plus 1 mod 2. Because when this is 0, this will become a 1. This will mod it by 2, and it will keep it as a 1, and it comes in as a 1. Next time that this runs, I don't need any of this. Next time that this runs, this 1 plus 1 will give us 2. Mod 2 gives us 0. This comes in as 0. We don't even need the is even row anymore. Check that out. We have fully removed the use cases where we had to use this variable. Can I just, and when we start this, we start with a current row of 0 and we start with a current index of 0. So we make our little helper method to pass those two things in. I knew I wanted to do this recursively for a reason. Whoa, that got so much cleaner. If I run it, nothing should have changed. It should work exactly the same. I am literally so proud right now. Whatever. That was awesome. I'm stoked that I felt in my bones that this would be nice recursive and that I went for it because it is super nice recursively. Obviously, like on a term test, going from the iterative solution to the recursive solution might not be feasible because that took forever. But for practice, that was super enjoyable. I'm very glad that I did that. It works in this scenario because my char matrix doesn't need to be like is a reasonable size. But if this was too large, we could end up with a stack overflow. For sure, we would end up with a stack overflow. Because we don't really need this to be recursive. This would be more space efficient if it wasn't, but it is so beautifully written with recursion that I'm still glad that I went through the process of doing it. Okay. Anyway, that's great. I enjoyed doing that. I've left you a couple of methods to fill in. I've also given you a practice situation where you could practice creating a tic-tac-toe game, or you could take in like a Sudoku file or like a Sudoku, or you could like hard code a Sudoku game and ask yourself, did somebody fill it in correctly or not? It's like a Sudoku validator style game. You can ask ChatGPT to give you a text file with a Sudoku. I'll like just show you. This is so silly. This is the joy of doing this online, is that I can just show you what I want you to ask ChatGPT. So you could literally ask ChatGPT, can you give me a hard-coded Java 2D array that signifies a valid Sudoku, a valid filled in Sudoku, right? So it will give us a 9x9 grid filled in a way that we would get a valid winning Sudoku. So then you can copy this into a practice problem where you can now validate that this Sudoku should come back as, yes, you won. We also could, I'm just going to stop the generation, ask now, now can I have a Sudoku variable that has an invalid Sudoku in it? So check that out. So now it can also give us one here that would give us an invalid Sudoku for whatever reason. It has, oh, look, it says it's having the number 9 appear twice in one row. So this allows us to check that type of error. We could have the same 2 9s in the same row, 2 9s in the same column, 2 9s in the same diagonal, right? There's lots of different ways to test for invalid Sudoku. This is only one of them. You have to check every like 3x3 square for Sudoku. So you'd have to like make this into a Sudoku situation, this one and check each of those. So there's lots of really different unique edge cases with Sudoku validation that you could practice. There's also magic squares that you can practice with. You can also say, can you give me that Sudoku, but in a text file format that I can read into my Java program. And in this scenario, it will just make it for you without all the extra brackets and everything like that. And it will just give it to you as a text file that you can now like input in using file IO and practice some file IO. So really great use of ChatGPT rather than you sitting there trying to like hard code these arrays or like make the file or whatever else, because that would be such a waste of all of our times. Let's just go ahead and look at the file that it just made for us. Right there. And we could practice reading that in and testing it out just as another option. Okay, so that's the pause and practice here. Now, my final video is going to show multidimensional arrays like a 3D array and reading in from a file and setting all of that up. So it's going to be a really long video of me doing a lot of code. I'm just letting you know because, of course, if you feel really comfortable already, perhaps you don't want to watch the video, perhaps you want to try yourself, whatever it may be. This is just an option. I just wanted to give you lots of practice code and lots of opportunity to see me manipulating multidimensional arrays because they can be really like cognitively tricky. Like it can really mess with our brains. Okay, so thank you so much for watching this practice video, and hopefully you will come and watch my 3D practice video next.